Have you ever applied for a loan, or a new job, or even just seen a weirdly specific ad and thought, how did they know that? Well, chances are an AI system somewhere made a judgment call about you. But the real question is, how did it decide? And was it even fair?
So to really dig into this, we're going to be pulling from Chapter 3 of a document called Ethical AI and AI Security, a comprehensive glossary, which was put together by Virtualization Options LLC. It's a fantastic guide for breaking down how these huge, life-changing decisions are being made behind the scenes.
And this really gets to the heart of the matter. More and more, these really important decisions are being handed over to AI. But for most of us, these systems are total black boxes. We get a yes or a no, but we almost never, ever get the why.
Now, you might think bias only comes from feeding an AI a bunch of bad, biased data, but it's actually way sneakier than that. The source material makes it clear that algorithmic bias often comes from the design choices made from the very beginning. So for instance, if you build an AI to screen resumes based on who your company has hired in the past, well, it's just going to learn to repeat any discrimination that was already happening. The bias gets baked right into the system's DNA.
So if algorithmic bias is the hidden problem, how do we actually see its effects out in the real world? Well, it leaves a footprint. It shows up in the numbers as a measurable symptom that we can actually track and identify. And this is where it gets really interesting.
That symptom has a name, disparate impact. And this chart shows a classic way to spot it using what's called the 80% rule. The idea is pretty simple. If an AI selects, say, 50% of applicants from one group, it should be selecting at least 80% of that rate from another group. So 80% of 50 is 40%. But look here, it's only selecting 30%. That's a huge gap. Now, this doesn't automatically prove something illegal is going on, but it is a massive red flag. It's the statistical smoke that tells you there's probably a fire of unfairness that needs investigating.
Okay, so the problem is just a biased machine, right? Simple. Well, not so fast. It turns out there's another really critical piece to this puzzle, our own psychology, and specifically, our tendency to put a little too much faith in our automated helpers.
So there's this fascinating psychological quirk called automation bias. Have you ever just blindly followed your GPS, even when the road ahead looked totally wrong? That's it, right there. We tend to think of AI as being objective, less flawed than we are, and that trust can make us ignore our own gut feelings. This is exactly why just saying, oh, we'll have a human in the loop, isn't some magic fix, if that human is already wired to just trust the machine.
And here's how that can go terribly wrong. The source gives this really powerful example. Picture a radiologist looking at medical scans. They're swamped, they're under pressure. An AI assistant, which is normally super accurate, fails to flag a tumor that's right there on the screen. The radiologist might even subconsciously notice something's off, but because the trusted AI didn't say anything, they defer to the machine and sign off. And just like that, the AI's error becomes a real-world, life-threatening failure because of this cycle of misplaced trust.
So we have biased machines, and we have humans who are biased towards trusting those machines. It sounds pretty bleak, I know. But there is a way forward, and it all starts by demanding that these black boxes finally start talking back and explaining themselves.
And that brings us to this key concept, explainability. It's really just the ability to get a clear answer to that simple question, why? Why was my loan application rejected? Why was this person's resume flagged? I mean, think about it. Explainability is the absolute bedrock of accountability. It's what lets us trust these systems, fix them when they're broken, and, most importantly, challenge the decisions that shape our lives. Now, when it comes to getting that explanation, the folks building these systems have a pretty fundamental choice to make. There are basically two very different ways to design an AI that we can actually understand.
On one side, you've got what's called the glass box approach. These are models that are transparent by design. Think of a simple decision tree. You can literally follow the path from the question to the answer. The trade-off? Well, they're usually less complex, so they might not be quite as accurate for really tricky problems. Then, on the other side, you have the black box approach. These are the super powerful, high-performance models we're always hearing about. They give you the answer, and then you have to use a separate tool to try and generate an explanation after the fact. This lets you have the best performance, but that explanation you get, it's just an approximation, a plausible story that might not actually be the whole truth.
At the end of the day, it all comes down to this really simple but powerful idea. If we're going to trust these systems with decisions that truly matter, if we're going to hold them accountable when they get it wrong, an answer just isn't enough. An answer without an explanation is just an assertion, and we deserve a lot more than that.
And all of this leaves us with the million-dollar question, doesn't it? When a biased algorithm makes a bad call and a human reviewer, who's influenced by their own automation bias, just waves it through, who's actually responsible? Is it the person who wrote the code, the company that used it, the reviewer who clicked approve? That is the incredibly complex challenge that we all have to figure out now.